Good morning, and once again welcome to my YouTube channel, Pearson at Excel International Maths. And in this video we continue to explain at Excel International IGCSE 9 to 1 Mathematics A and Book 2, and we are getting to topic number 3, which is sequences. And I want us to get to page 43 and understand something about sequences. Well, we have to go through the literature on page 43 so that we can understand the learning objectives, we can understand the basic principles, and we can understand what is it that we are expected to know. Of course, there's an old man there who lived between 1777 and 1855. It's good to know why he's there and what he did. But I want us to just go directly to the sequences and say something about it. And we are going to discuss today about continuing sequences. Yes, we are talking about continuing sequences because they are those which converge. These are diverging the continuing or diverging sequences. And we are told down there that a set of numbers that follows a defined or a definite pattern is called a sequence. And of course, when we have a set of numbers that follows a definite pattern, that is a sequence. Even 1, 2, 3, 4 natural numbers are it's an example of a sequence because they follow a certain pattern. For example, we keep adding 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. We keep adding 1. That's the law. You can continue a sequence if you know how the terms are related. And of course, there is an activity on page 44 before we go to example 1. And we are told that Seema is decorating the walls of a hall with balloons in preparation for a disco. She wants to place the balloons in a triangular pattern. And to make a triangle with one row, just this, there is one row here. We're talking about this is one row. To make a triangle with one row, this is just a row. She needed one balloon. And to make a triangle with two rows, this is one row and the second row, she needed 3 balloons. And to make a triangle with 3 rows, this is 1, 2, 3, she needed like 6 balloons. And we are told down there that the number of balloons needed form the sequence 1, 3, 6. And describe in words how to continue the sequence and find the next 3 terms. Of course, we are to see sometimes it's good to do things practically, and you may have one balloon there, and you may have the other one is one balloon, and the other one is just like this, and the other one is one balloon, and there is that one, and there is that, there is that, there is that. The other one, I think it will be, there is one balloon there, there are these ones, then there is the third row, and of course will be the fourth row, 1, 2, 3, 4. So how many balloons do we need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10. Of course, to the next we need more 5. We need the next row, which is we are going to have 1, 2, 3, 4, 5, and we are going to have 15, and of course I'm supposed to go to 21 having added 6, and so on and so forth. And somebody is talking of Seema thinks she can work out how many balloons are needed for n rows by using the formula by using the formula half n n plus 1. Her friend Julia thought this is Seema, and there is her friend Julia who suggests that the formula is not going to be this, it's going to be a half n minus 1. Who is right? Let's find out. We have just found out, we can even use this. We have just found out if we need balloons with the 4 rows, we are going to require 10 balloons. 1, 2, 3, 4. And all these are 10 balloons if we count them again. So if n is 4, because the n signifies the number of rows. So let's talk about a half times 4, and then 4 plus 1 is 5. By 2 by 2, 2. 2 times 5 is 10. This one looks correct. The other one is a half 4. 4 minus 1 is a 3. And this one is 2. 2 times 3 is a 6. This one is wrong. So Seema herself is right. Her formula is correct. But anyway, let's get back to example 1 and probably example 2 in this video. That was just introduction. Let's talk about example 1. Write down the first 5 terms of these sequences, starting with -8, -8, and keep adding 4. So the 5 terms is -8. The second term, -8 plus 4 is -4. -4 plus 4 is 0. 0 plus 4 is 4. 4 plus 4 is 8, and moving forward. What about starting with 1? Starting with 1 and keep multiplying by 3. And then keep multiplying by 3. So the first time is going to be 1. 1 times 3 is going to be 3. 3 times 3 is going to be 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243, and moving forward. That is exactly what we need. That is as far as example 1 is concerned. If you look at example 2, for these sequences, let me just display it. It's simple. It's just a simple thing. For these sequences, describe a rule for going from one term to the next. And we have 5. We have 5, we have 2, we have -1, we have -4. Of course, it goes without saying, this one we are supposed to be subtracting 3, because 5 minus 3 is 2. 2 minus 3 is -1. And -1 minus 3 is -4. If you want to get them to the next one, -4 minus 3 is -7. Moving forward. What about 288, 144? Already, 288 to get to 144, you can already see this is divided by 2. From 144 to 72, again divided by 2. From 72 to 36, again divided by 2. So the rule is dividing by 2, and these are the solutions to that particular question. So you must exactly understand what we are doing. So if you want to go to the next term of this sequence, now 36 divided by 2, obviously you're going to realize it is an 18. And therefore, please again go to my YouTube channel, subscribe and share widely, and let us look forward to understanding mathematics together.